Question number 9 gives us f of x in red as 4 minus square root of x squared minus 3, and g of x as x squared plus 3. And we're asked to determine the three different ones, a, b, c. And we want to be able to answer question 10 as well. What are the domains of the combined functions? We're going to do that at the same time. So for a, f of x, or g of x minus f of x, is going to be x squared plus 3, then minus 4, bracket of 4 minus square root of x squared minus 3. Okay, so we're just basically putting them together. We can simplify some of these things. In this case, we could make this into y equals x squared plus square root x squared minus 3, and then minus 1 as our ones term. Okay, so that's not super important, but what's more important is the domain and range for this. So when we take a look at the domain of this function, the x squared plus 3 has no restrictions on the domain. The x squared minus 3 has no restrictions. However, the square root does have restrictions. In fact, this square root, the inside part of the square root, is going to determine our restriction on the domain. So there's certain values of x that won't be allowed. So if I graph x squared minus 3, this is what I have here in yellow. And I have x squared minus 3 has to be equal to 0 or bigger. And where I've shaded in green is the parts where x squared minus 3 is going to be bigger than 0. Okay, so it's a parabola with vertex at 0, negative 3, and the intercepts are going to be at negative root 3, positive root 3. So any values of x that are bigger than root 3 or less than negative root 3 will give me positive values of x squared minus 3, which then allows me to square root that number. So my domain for this function then ends up being x must be less than or equal to negative root 3, but it could also be bigger than or equal to positive root 3. So that becomes my domain, and it's only restricted, so that's going to be an x value here, and it's only going to be restricted by that inside square root function. For part B, we're being asked to find f of g of x. So f is on the outside, so I've kind of drawn that in red, and then g of x is going to be embedded on the inside of this. So g of x, if we recall, is x squared plus 3. Okay, so there's my composite function. In terms of the domain of this function, we can kind of think of it this way. We know that the output of this x squared plus 3, it has to be bigger than 3. Because of the x squared plus 3, the lowest point, the vertex, is going to be at 0, positive 3. And then if we square that number, we're going to get a number bigger than negative 3. So what ends up happening here is the output of the g of x is going to be bigger than 3. It must be. And the input must be, in this case, it's got to be bigger than, positive root 3. Okay, so I'm going to just adjust this here. So we establish here that's got to be bigger than positive root 3. Okay, and we don't really need to worry about the negative side of this because we know that all the values that we're going to get are going to be on the positive side anyways. So anything that gets outputted of the g function can be inputted into the square root function or the f function. And so we have no restrictions in our flow chart here of our function flow chart. So in this case here, the domain for this is going to be x's all real numbers. Lastly, for C is asking us to find g of f of x. So we're going to have the g on the outside and f on the inside. So it's going to look like this. We're going to have x squared plus 3 on the outside, and on the inside, we're going to embed 4 minus the square root of x squared minus 3. Okay, so there's our function. We can expand this out and combine like terms. Again, that's not really uh, all that important, although we should be able to algebraically manipulate that to do that. What's really more important here is understanding the domain of this function. Okay, the domain restriction is going to be coming from the square root function. So again, my flow chart is going to look like this. I'm going to have my x. It's going to go into my g function first. Sorry, my f function. And in the f function, we've already established that it must be less than negative root 3 and greater than positive root 3 from this graph here. Okay, so then we have a restriction on that function. Coming out of that function, we're going into the g function, there's no restriction. So anything that comes out can go into the g. So there's no restriction in this spot here. So the only restriction that we have is the original f of x. So in this case, the domain of this combined function is defined by the restriction on the f function, which you establish as it's got to be less than or equal to negative root 3, and it's got to be greater than or equal to positive root 3. Okay, it's got to be one of the two. So that is the domain of that g of f of x function.